Hi, everyone. Thank you for joining us today. My name is Emma O'Neill. I'm a structural engineer at PTL Structural and Fire, and I'm on your TDS committee. Today, we've got a bit of a different webinar situation because Andy and Robert have joined us in our office, so we're all going to be coming to you live, so hopefully there's no bugs, but let's get into it. Before we get started with today's webinar, just a bit of housekeeping from TDS. The next webinars that we've got coming up are on November 21st. We've got Mass Timber Structural Golden Rules from Nick Hewson. And we've got on December 12th, Hydrogen Embrittlement of Engineered Wood Screws with Eric McDonald, Bjorn Stankiewicz, and Felix Scheibmeier. If you've got any other topics that you're interested in that you'd like to see about a webinar or technical notes in the journal, please feel free to let us know. I've put up a QR code that you're welcome to let us know if you have anything you want to hear from us. Thank you, as always, to our sponsors, FutureBuild, MyTech, Simpson Strong Tie, XLM, iBuilt, and Rotoblas. Without their support, we wouldn't be able to do all these activities, so that's very great. On to today's webinar. Today we've got Robert Finch and Andy Buchanan that are going to be talking to us about fire safety in mass timber buildings. Robert Finch was the director of Timber Unlimited, which was a collaboration between the New Zealand Timber Design Society, Wood Processors and Manufacturers Association, Brands, and Scion. The center was hosted at Scion and financially supported for establishment through the Ministry of Primary Industries, Te Uru Rakau. Andy Buchanan is the chair of the New Zealand Commentary Working Group that he's going to be talking about today. He's a semi-retired structural engineer who works with PTL Structural and Fire in Christchurch. He is a professor emeritus in civil engineering at the University of Canterbury, where he set up the fire engineering program over 30 years ago. And he is one of the authors of the Structural Design for Fire Safety, and editor of the New Zealand Timber Design Guide and the Global Design Guide. In today's webinar, Robert and Andy are going to be talking to us about the 2024 New Zealand commentary on the Global Design Guide on fire safe use of wood in buildings. This commentary gives recommended design methods for fire safety in mass timber buildings, describing essential tools for assessing fire severity, providing structural performance, preventing fire spread, and providing safety for firefighters to meet the requirements of the New Zealand Building Code. So I'll pass it over to Andy.
Okay. Good morning. Good afternoon, everyone. It's a pleasure to be here. So this is the topic of the talk, the New Zealand commentary on the Global Design Guide, and I will describe what all those are about in a few minutes. Some of you know this about them and some of you don't. I'm giving the talk, so my name is there, but I just want to point out that the contributors to this design guide, there's a whole range of people here. And I'll just point out here quickly, going through this, you can read the names yourself. I'm not going to read them all, but there are people here from designers and regulators and researchers and teachers. And the bottom name on that list is Robert Finch from Timber Unlimited. So I'm just going to pass over now to Robert, and he's going to say a few words and tell you how this whole process came about. Robert.
Good afternoon, everybody. Thank you, Emma and Andy, for that. The first thing I'd like to do is just actually thank the Timber Design Society for inviting Andy and I to talk to you today. The last time I think I spoke to Timber Design Society was probably back in 2022, middle of 2022, at about the time when Timber Unlimited started. Anyway, thank you for the opportunity. It's greatly appreciated. So I'm just going to do two things, and it'll only take me 3 to 4 minutes, and then I will hand back to Andy. He'll actually take you through the details that you're actually waiting to hear. So I'm going to give you a little bit of background, how it came about, and so on, and how it evolved, and then I will turn to a few acknowledgements, and then that'll be me. So in terms of background, funding was approved for the project by at the time, Timber Unlimited Governance Group in late 2022, and the project itself commenced in early 2023. And the project ran through until completion in August 2024, so just gone. And this is despite the fact that TU ceased formal operations at the end of March this year. And the commencing objective was actually to develop a New Zealand commentary to the Global Design Guide. However, following the first round of industry consultation that we did, which was back in April last year, the scope of the project was expanded. And so in effect, we turned it into a two-stage project. And stage one actually became a requirement to address an urgent need to firstly develop and publish an interim guidance document on recommendations to the supplement AS2 and C VM2 in the building code, and then subsequently to do what we set out to do, which was to prepare the New Zealand commentary to the Global Design Guide. So it was in two parts effectively. The interim supplement document was completed and published in late 2023 following extensive industry consultation and peer review. And although the document was only 13 pages long, believe it or not, it went through many iterations and took considerable effort to achieve a balance of recommendations that were acceptable to everybody who had an interest, including the timber suppliers, the designers and specifiers, the fire and structural engineering communities, FENZ, MBIE, and the territorial authorities. In short, it was a bit of a mission, but we got there despite the shortness of the final piece. And during stage one, the writing of the NZ commentary itself was largely put on hold because stage one took the precedence at that stage. The New Zealand commentary was then written, laid up and published on the TU website in August 2024. And this document is currently published, as you'll see from what Andy has to say to you, as a draft for public comment. I just want to make a note on that. The reason for this is that due to the cessation of Timber Unlimited's operations at the end of March this year, there was no further funding that could be applied to industry consultation and peer review processes. Hence, all those interested in fire engineering guidance for multi-storey and mass timber buildings are urged to go to the TU website and download the document. It's free to download. Look through it, use it, provide feedback and commentary via the email address that's contained within that document. Having said that, I've just become aware in the last 24 hours that there is something wrong with that email address, and it's probably going to take a few days to fix. So if someone tries to send something to it right now, it'll probably just bounce, but it should be fixed within the next few days. The other thing we should note is that the commentary is actually something that can't be used on its own or shouldn't be used on its own. It is a commentary to the Global Design Guide, and so you need both things together. Now I just want to turn to a few acknowledgements and then I'll stop at that point. So I'd like to thank the following in particular, the Timber Unlimited Governance Group, for understanding one of the barriers to more use of timber in large buildings, being the lack of clarity and guidance on fire engineering, and having the wisdom to approve the requested funding to carry out the project. I'd like to thank the authoring and contributing team, which has been headed up by Andy, as Emma said, who effectively had three roles: the author, an author, the project manager and lead, and the editor. And the entire team that included Tony Abu, Omar Abu Holo, Greg Baker, Angela Chen, Ed Claridge, Martin Feeney, Kevin Frank, Devin Glennie, Ben Graves, John Harris, Paul Horn, Dennis Powell, Colin Wade, and Peter Whiting. I'd also like to thank Kate Smart, who was with Timber Unlimited at that time, for the professional layup and publishing of both the documents, and the timber industry and many fire and structural engineering people for taking the time to review and provide feedback on the early versions of the supplement document, which was the end of stage one. And finally, MPI Taiuru Raku for funding Timber Unlimited to commence the operations and to carry out multiple high priority industry projects, including this one. So I'm going to stop at that point, and I'm going to hand back to Andy now, who will actually talk to you about the documents in question. Thanks.
Okay, thanks, Robert. Thanks. And Robert has introduced us to a lot of what we're going to be talking about. And I'm going to get moving because I've got a lot of slides, and some of them I'm going to go through rather quickly, but let's get on with it. I don't have to tell you this. What is mass timber? Well, it's glued laminated timber, glue lam. It's laminated veneer lumber, LVL, for long, straight and strong things. And it's cross-laminated timber for walls, roofs and floors, anything you can make out of large flat panels. Let's jump right into fire safety. What is the problem? It's as simple as this. The architect and the building owner and the supplier, they want to expose all the wood that they can, but the regulators want to hide as much wood as they can because they're afraid of it reducing the fire safety of the building. So that's really why we're here, and that's why all these documents have been written, because there's a tension here between the architect, owner, and supplier who want to expose the wood, and the regulators who are correctly nervous about this because if there's too much wood, it reduces the fire safety. How do we address this tension? Well, there are 3 documents which Robert's been talking about. Document number 1 is the Global Design Guide, which was published in 2022 with a lot of help from Kiwis, although it was published in the US with assistance from Europe and America and Canada and Australia. And then secondly, the New Zealand supplement, which Robert's been talking about, which was published in 2023. And thirdly, the New Zealand commentary, which is the complete New Zealand guidance document, how to use the Global Design Guide. And that supplement actually appears as Appendix A in the commentary, but they're listed 1, 2, 3 because that's the order in which they were produced. So let me say a bit more about each one of those, because it's a little bit tricky, but at the end of the day, there's lots of information there. So the Global Design Guide was launched at FireNZ in 2022. That's the cover of the book. You can buy a hard copy book. It's not cheap, but you can buy it from anywhere that sells books. And you can get a free online version from the Timber Unlimited website, or just Google it, lots of places. And what's in there are 14 chapters. I'm not going to go through them all because we'll be going through them all again. But the authors were from 12 countries, including several from New Zealand. And so that was the original document, but it was a global document and it did not refer to the New Zealand Building Code. It wasn't really useful to New Zealand designers. So that's why we decided to write a New Zealand commentary. But on the way to that, we said, let's write the conclusions first, because people need to know what to do right now, just as Robert said. And this is a supplement to the acceptable solution and the verification method. And that's why we call it the supplement. And the objectives were to remove uncertainty in the design and construction of multi-storey buildings, especially multi-storey mass timber, to show what's possible and to help owners, developers, architects, engineers and regulators and the timber industry so that everyone is on the same page. This is not a building code. It's a guidance document. But the whole intention here was that if the guidance document had been written by the entire spectrum of people, from the designers and suppliers and regulators, then we hope it will be a useful document for everyone to use. And there may well be changes to the building code along these lines, but not yet. Okay, just to say what's in there is a design flow chart with 3 design approaches. This is all obvious stuff. Fire engineers know all this. The prescriptive design, a verification method, and a performance-based alternative design for buildings which are out of scope of the document. The flow chart looks like this. I'm not going to spend any time on this, but it's a very useful flow chart. Angela Chen at FENZ drew this flow chart for us, and it just is a guidance of how to get through the document and which buildings it applies to and which ones don't, and when you've got to do an alternative solution. A few details in there. This table is a very important table in there, and if you're doing a prescriptive design, and so this is really aimed at architects and engineers and builders who are not fire engineers, that you can see here on the left-hand side, we've got different heights of building, because height is very important. And then we've got sprinkled, unsprinkled buildings. And you can see here, if we're less than 4 meters in height, in other words, 1- and 2-story buildings, we just follow the 30 or 60 minutes from the building code, and you can put in as much wood as you want, WU, wood unlimited. If it's unsprinkled building, well then, as the building gets taller, you can expose less wood. That's for unsprinkled. And for a sprinkled building, you can use more wood. And you can read all that stuff there. I'm not going into any detail, but I am going to explain what do we mean by this W100, W200. And the WU is unlimited. W200 means you can expose wood up to 200% of the floor area, lots of wood. W100 is intermediate. W0 is exposed no wood. It's full encapsulation. And I'll quickly give some examples of those. So for a wood unlimited, you'd be looking at a room like this with exposed wood floor and ceiling and walls, or a space like this, a corridor, all the wood you want to. As the building gets taller and more important, we're saying let's cut it down to 200, expose the floor and the ceiling, for example, or expose the floor and the walls, but not the ceiling. And if we go to 100, we're talking about less, just the ceiling, for example, and the same thing there, and the same thing there. And that is often all that's required. The W0 is for zero exposed wood, and it's a building like this. You can see a lot of wood here, but it's all being encapsulated. The gypsum board is all being placed, and there will be no wood visible in that building. And this building, the Brock Commons building in Vancouver, which was for a short time the tallest mass timber building in the world, you can see a lot of wood there during construction, but when it was finished, every piece of wood was covered in 3 layers of type X gypsum board, and there was no wood exposed at all. Why was that? And that was because the fire authorities would only allow that tall residential building if that was the case. Sometimes there's an intermediate case where there are just beams and columns, and if there are beams and columns with no flat surfaces, then there's not a whole lot of wood to get involved as fuel load, and so this could be considered zero, but there's a question mark there because it has to be considered on a case-by-case basis. Okay, a couple more things about the supplement. It talks about full encapsulation or some exposed wood. And for the full encapsulation case, the fire engineer can ignore the wood. Just use verification method VM2 with a few changes for tall buildings. If there is exposed wood, well then that wood has to be included in the fire load. And this is really the reason for all of this stuff, because the New Zealand Building Code does not anticipate an exposed wood structure which might double the fuel load, because it's all written around steel and concrete buildings. And so the story here is that the fuel load, the wood which is exposed must be included in the fuel load for the engineering calculations, and all the other wood has to be encapsulated. And the methods for doing that are all in the Global Design Guide and the New Zealand Commentary. So there are a few more recommendations in here, which I just go through very quickly to address real problems in real buildings. It's okay to expose wood in stairwells and lift shafts. All gaps and joints must be fire stopped. Evacuation zone boundaries have to be encapsulated. Structural fire calcs, I'm going to go into it in a bit more detail. Fire safety during construction, very important. I'll come back to that. But these special things really are for tall buildings, because these concerns about fire safety in a mass timber building, they are just not a problem for 1- and 2- or 3-story buildings. But when we start getting to 5, 10, 15-story buildings, then there are big concerns. And so that's why this stuff is all related to height. Okay, that was document we've had two documents now. We've talked about the Global Design Guide and we've talked about the supplement. I'm now talking about the third document, which is really the talk of today, which is the New Zealand commentary, which was just published in August, and that's the cover of it. It's, once again, all of these documents are free online as PDFs. They're available on the Timber Unlimited website, and this part of it is a draft for public comment, and comments are welcome. However, as Robert said, the comments are not going to be addressed very quickly until there's a funding mechanism to do that. And we watch this space. But if you have comments to make, you can address them through the website, or you can come directly to any of the authors. Okay, so that's now on the right-hand side, that's the table of contents of the commentary. And there are 14 chapters there, and they're the same 14 chapters, guess what, as in the Global Design Guide. And so this document has been written alongside the Global Design Guide. And also there in small print, you probably can't read, but all the authors of each chapter are there, and they're all people in the New Zealand fire engineering community. So there are the 14 chapters, and then off the bottom of the list, Appendix A is the supplement that we've been talking about. So we said there were 3 documents, there are really only 2, because the supplement is now Appendix A to the commentary. So this is very important. Robert said this. If you're going to use this stuff, you must read 3 documents side by side. That's the Global Design Guide and the New Zealand commentary and the supplement, which is in Appendix A of the commentary. So the commentary's got the same numbering system. We tried to avoid repetition, but you'll have to go back sometimes to get justification and guidance, because lots of stuff, graphs and photos, are in the Global Design Guide, and for copyright reasons and other reasons, we haven't repeated that stuff in the commentary. You need to look at both documents. But if you've got 2 screens on your computer, it'll be no trouble at all. Okay, so what I'm going to do now is run through these chapters one by one. And I can't tell you a whole lot, but I can tell you a little bit about each chapter. So chapter 1 is about timber buildings and timber and wood products. And what it describes is what's different in New Zealand. It says something about CLT and LVL and where they're available and what their properties are. So there's no fire engineering in chapter 1. It's just about wood properties and timber buildings. Chapter 2 is a sort of fire safety 101, if you like. It's an introduction to fire safety for non-fire engineers. And it talks about fire safety in lots of buildings, but especially in tall buildings, as I mentioned before. These are tall buildings, tall timber buildings, and fire safety in those is very important. There are 3 or 4 words I want to talk about here because they're explained here. The first one is the concept of fire resistance. And you all know about fire resistance. It's 30-30-30 or 60-60-60, which relate to the structural performance and the integrity and the insulation. That's old stuff. If you want to know more about encapsulation, I'm going to mention encapsulation a bit more, but encapsulation is defined in chapter 2. And the third thing in there is this concept of burnout. And by burnout, we mean a fire occurring in a building and no intervention, sprinklers not working, fire brigade unable to get there, and so the fire is left to burn itself out. And that's really the fear in a timber building, is when will the fire go out? And when we started writing this, we said, well, you just wait until self-extinguishment occurs. But I've crossed that word out because we don't use self-extinguishment because it's such an emotive word. It means different things to different people. And a fire in a timber building, the flaming will stop, but the charring may never stop. And so we can't guarantee self-extinguishment. At some point, the firefighters are going to have to get into that building and do something about it. So that's just a definition of those terms. Okay, I'm going to jump to chapter 3, fire dynamics. What is going on inside this building with all the flaming of the fuel in the building, and the fuel also including exposed wood. And you can see a picture there with huge flames coming out windows, and that's something that's going to happen. If you double the amount of fuel in the building, you will extend the duration of the fire, and you will have much bigger flames out the windows. The severity or the temperatures in the fire may not be much different, but the duration of burning and the flaming out the window increases. So go back. Now, Colleen Wade, who was at Brands, this is her chapter, and she wrote this chapter in the International Global Design Guide, and what's in the commentary is just an update of that, and what Colleen has done is just brought it back to New Zealand conditions, and the main part of it is what we call the iterative method for fire severity, and often called the Brandon method, because Daniel Brandon in Sweden developed this method to calculate the fire severity in a compartment with exposed wood. And then what's also in here is there's some relaxation to that method, some limitations, some details, there's some recommendations for external fire spread, and some information on the char depth calculations, because there's an output of the iterative method is the char depth when the flaming combustion stops. And there are also worked examples in there. So from a fire severity point of view, for a fire engineer starting work, especially for VM2 or alternative solution, this is the critical chapter to get into. This tells you about the fire. Chapter 4 is about the building code requirements. In the original design guide, it's got a comparison of all the countries of the world. But what Devon Glennie from MBIE has done in the commentary is he has just zeroed in the New Zealand requirements. And one of the things that he's pointed out in there is that there's a big gap between New Zealand and many other countries. And I'll just show this little chart, which is in there, and it was taken from Build magazine in 2021. And what it shows is that in these 3 countries, if you compare the fire resistance ratings, and I'll just zero in on an 8-story building. So in New Zealand, where you'd need 30-minute fire resistance for an 8-story building with sprinklers, in the US, it would be 120 minutes. In Australia, it would be 90 minutes. And so our fire resistance ratings, and this is not just for wood, this is for all materials, but if the wood is involved, then we get more concerned about it. And so if you want to know more about that, read chapter 4. Okay, chapter 5, reaction to fire. We're talking here about the early fire hazard, and these are photographs which Ed Claridge from Auckland Council has put in, because these are buildings he's been involved in, and these are places and buildings where we have to address the group number to avoid rapid flame spread over the surfaces. And so these restrictions and the types of coatings available and the New Zealand building code requirements for group numbers are all in chapter 5, along with the translation of the European requirements, which was done when the group numbers were introduced, to make sure that equivalent products from other countries can be used. And so that's all there in chapter 5. Chapter 6, I'd have to say here, we're going to see 2 chapters, because chapter 6 is about fire separating assemblies, and chapter 9, a bit later on, prevention of fire spread within structures. There's quite a lot of overlap between these chapters, but Ed Claridge put this chapter together, and Dennis Power put chapter 9 together, but I'll just let you know, you may find that you get referred to another chapter. But the separating assemblies are all about how to produce walls and floors which have got fire resistance ratings to prevent the fire spreading from one compartment to another. So on the left-hand side there, we have a photograph of a fire resistance test of a mass timber wall element. And the left-hand side of the left-hand picture, there is an intermittent fire retardant product on there, which has swelled up and stopped the flaming. But on the right-hand side, there's bare wood and the flaming continues. And so that's talked about in Chapter 6. The right-hand photograph is the failure point. That's an integrity failure of a mass timber floor. And just what you can see in that photo, that floor has got lots of thermocouples, all numbered there at a random location on the floor. And for that floor to have an insulation failure, the temperature at one of those thermocouples would have to have exceeded 180 degrees or 140 average. But what sometimes happens is that there's a failure remote from the thermocouples, and that's called an integrity failure. And so when we go back to the 30-30-30 rating, 30 minutes is carrying the load, 30 minutes is no integrity failure like we're seeing in that picture, and 30 minutes is for no insulation rating. And those ratings, as far as those ratings are concerned, we can make a good job at calculating the structural performance. We can also calculate the insulation performance if we know the thermal properties. It's much harder to calculate an integrity failure, and that's why we still need large-scale fire resistance tests. We can't do it all by calculation, and all of that stuff is spelled out. Chapter 6 of the Global Design Guide, modified for New Zealand conditions in the New Zealand commentary. Okay, we're now, well, sorry, I've said all this stuff. This is also in Chapter 6, the criteria, the test methods, protective materials, encapsulation is defined again, and it's a bit tricky. Full encapsulation means there's full encapsulation, so the wood never sees the fire and it doesn't get hot. And then we've got to be very careful with these words about partial encapsulation and limited encapsulation, and because there are two issues here. One is not thick enough encapsulation, so the wood starts charring after a certain time. And the other problem is where you've got encapsulation on some walls and not the other. And you've got to look up the definition before you use those tools, and then calculation methods. Okay, I'm now jumping to 7 and 8, because 7 and 8 are for structural engineers. 7 is load-bearing timber structures, structural performance, and Chapter 8, next one, is about timber connections. So Tony Abu from the university, with a bit of help from others, wrote Chapter 7, and Paul Horn from Becker and the university wrote Chapter 8. But I can only say a little bit here, but Chapter 7 is actually, there's some interesting stuff here. So for the structural engineers listening, you should all be aware of the joint standard, AS/NZS 1720 Part 4. This has not yet been adopted by MBIE, but it is what most people are using. And it's a companion document to the new 1720 Part 1, which is the new Timber Design Code. Because the old document, 3603, had a chapter on fire. The new NZ 1720 Part 1 says nothing about fire because it's here in this document. And the new thing which appeared in there from the 3603 was the zero strength layer of 7 millimeters. However, there's a lot going on in the world of structural fire engineering, and the next little block of stuff are in Eurocode 5, because we're watching what goes on in Europe, because they're more advanced than we are. And what we've put into the commentary is we've put these other requirements in Eurocode 5. It's the same charring rate of 0.65 millimeters a minute for a plane surface, like a slab or a wall, but to allow for the corner rounding at the beams and columns, which used to be in 3603, the charring rates increased to 0.7 millimeters a minute. But the one thing that will worry some of you is that After a lot of research, the zero strength layer has been increased from 7 millimeters to 10 for tension and bending, or 14 for compression members. And so that will make a change. That makes things worse for designers. On the other hand, to increase the characteristic strength from the 5th percentile to the 20th percentile, you can increase the strength by 15% according to that. I'm not going to say any more. If you want to know the details of this, you go and look there. And same thing I would say is that these new requirements are not in the New Zealand Building Code, but they are the direction the world is heading. And if you're designing a very major, critical, tall timber building, then the recommendation is that you would use these new requirements. Just also to remind you that the iterative method, the Brandon method from Chapter 3, gives you the char depth, and the fire engineer must talk to the structural engineer. For a steel and concrete building, the fire engineer and the structural engineer can exist in different offices. They never talk to each other. But if you've got a mass timber building, you have to talk to each other because there's so much overlap. And the structural engineer must talk to the CLT supplier, because for most CLT that we have, certainly for Red Stag and XLAM, the design methods with charring, you don't go that way. You go to the manufacturer's load span tables and look at those. And if you've got a problem with them, you go and talk to them. Okay, that's Chapter 7. Chapter 8, connections. Here's a nice photo here of a connection with internal dowel plates and a sketch from the commentary, which Paul Horn has put together. And so this chapter talks about types of connections and junctions, exposed, concealed, examples, design approaches, detailing, protection. And this is not so easy. Designing beams and columns, in theory, it's easy. If you know how much charring there is and you know how much wood is left, you just do your design. But it's much more difficult for connections, especially if there's exposed steel. And what Paul has done in this part of the commentary, he's gone back and he's leaned on Eurocode 5, and he said, if you want to do it in a quick way and a conservative way, he's given some guidance from that document. If you want to dig into it and do it properly and thoroughly, the suggestion is go to Eurocode 5, because they are far ahead of anything else in North America or New Zealand, Australia, in terms of understanding the fire performance of connections like this. Okay, Chapter 9, prevention of fire spread. As I said before, it's a lot of overlap with Chapter 6, and that photograph there of an integrity failure is a different fire test, but it's the same problem. And what's in here are pathways for fire spread and how to manage those, and detailing of junctions and gaps and building services and fire stopping and penetrations. And the bottom left photograph there is a photograph of a whole lot of charring around a poke-through services penetration in a CLT floor, and similar to the one directly above it. That's a seismic gap. It's a bit different. But the point here is that if you're going to go to suppliers of fire-rated penetrations through concrete structures, that's not good enough. They must be tested in timber structures, because you get a lot of additional charring. And the manufacturers are coming through this, and one of the co-authors of this chapter, it was with we got some assistance from Ryan Fire, because they're the people who've done a lot of these tests, and I'd like to thank them for their assistance in this chapter. So that's Chapter 9. Chapter 10 is about sprinklers, active fire protection by sprinklers, and this is really simple stuff, but at the end of the day, it's not so simple. The simple thing is that sprinklers are fantastic. They're the best way you can improve the fire safety in a building. You get no flashover. If they work properly, you need zero fire resistance. However, they don't always work. we cannot rely on them 100% because there might not be enough water in the street. There might be down for maintenance. There may have been an explosion or an earthquake or something, and which we'd rather not know about, but we have to allow for that. And so for most buildings, we have to provide structural fire resistance for burnout, even if there are sprinklers, on the basis that we cannot rely on the sprinklers completely. So Martin's written something about that, and there's be more about that in chapter 12 I'll come up to in a minute. So these chapters at the end are less about practical details. They're more about the philosophy behind it and where to go. If you're doing an alternative solution and you want justification, go and see chapter 10. Chapter 11 is about performance-based design. It's a very long chapter in the original design guide written by Paul England, who more or less rewrote the Australian Building Code. This chapter Colleen's put together, but what we're trying to avoid is this kind of thing. So you can see in this graph here, a fire growth, ignition, fully developed fire, and then the fire going out towards burnout. And what we really don't want is falling off of protection so that we get a second flashover or a third or a fourth flashover. And the philosophy behind that is all written in here. And so Colleen talks about the principles of performance-based design, determine the objectives, define the fire scenarios, what are the pathways to compliance, and what is the risk assessment. So that's all in there. Chapter 12, Martin Feeney's put together a risk matrix, which is a very useful risk matrix. We don't have time to go into it now, but Martin has done this, and it looks at the risk factors and the failure consequences. It gives a background to the FM factor. You all know the factor which reduces the fire resistance for putting in sprinklers, the exposed surface area limits and so on, and the strength reduction with temperature, which is something, a bit of a red flag, which is only mentioned here and nowhere else. But what we do know, a lot of you heard John Mark Franson speaking at some seminars last year when he visited New Zealand, and we know that if you have columns exposed to fire, there's a thermal wave in the column which will reduce the strength as the fire's going out, even with quite low temperatures. I'm not going to say any more about it there, but it's mentioned there in chapter 12 and also in chapter 7. Okay, nearly at the end here, execution and control. There are two parts to this. It's really about fire safety precautions and documentation and avoidance of fire hazards like this. So two parts to this chapter: installation of fire protection, documenting the fire requirements, providing good workmanship, inspecting everything, make sure it all gets done. And the second part of it, which is really the biggest part of it, is fires during construction. And if you talk to people in the US and the UK, where there are more and more tall timber buildings, what's the problem? Again and again, the problem is fire during construction, especially fires started by hot works, when before the active systems, the sprinklers, before they're installed, before the jib linings and passive systems are installed. So this is a very useful chapter. And if you're writing the specification for fire safety in a tall timber building, add something in your specification and go to this chapter and take out the checklist. There's a lot of stuff in there with regard to staff training and liaison with FENZ. Okay, the last chapter is chapter 14, and I'll just acknowledge Omar, who's now moved to Australia, but Angela Chen at FENZ and Kevin Frank at FENZ and John Harris at FENZ, all of whom have helped to put this chapter together with some help from Ed Claridge. And there are diagrams like this, and there's because this was not covered at all in the global design guide. This talks about the New Zealand situation, which kinds of appliances we have in which cities, and how far they can reach. And So including, as we say, limited appliance, the number of appliances, the reach, pre-incident planning, overhaul procedure after the fire's out, the firefighting water demands, etc. And the takeaway point from this is that early engagement with FENZ is strongly recommended, because, as you know, the engineering section of the design review unit may well be looking at your building. And so earlier the better. Fire engineering brief. Okay, conclusions. Mass timber buildings are coming. We can't stop them, like it or not. Wood burns. If exposed wood is in the building, it's going to burn, and there are ways of reducing the flammability, but not really reducing the fire resistance. This affects the fire load and the structural performance. And this is why the fire engineer and the structural engineer have to talk to each other. Solutions are available. And in these three documents, the Global Design Guide, the commentary, and the supplement, they will all help with possible future code changes. But we need your help to make this work. So the authors of this we want to know what works in here and what doesn't work so we can make changes. Last little plug I'll put in. A lot of you will know the Fire Science Show. You can Google the Fire Science Show, but the latest recorded last Wednesday is number 172. And it's Wojciech, who will be here next week in New Zealand as a keynote speaker at Fire NZ. He's the host of this, and he's talking to Danny Hopkin, who's part of OFR with Mike Spearpoint in London, and they talk about fire safety in mass timber buildings, and it covers a lot of the things we've been talking about. So I just put that as a little plug, because if you don't know the Fire Science Show, you should try it and listen to the latest episode. Okay, that's all. I'm finished. Time for questions.
Thank you, Andy. That was great. We have a few questions here. And if anyone else has more questions, please add them in the Q&A chat box. So can you please elaborate on exposed timber, if it's okay in stairwells and lifts? Okay.
Yes, I have to say this is a contentious topic. In some parts of the world, in Europe, most of the European countries, you won't see any wood in a lift shaft or a stairwell. It's all non-combustible. As far as we've gone, the authors of the commentary, what we've said is that for buildings of a certain height, it's not a problem to use exposed wood in the stairwells and lifts, provided that the building has sprinklers. So that's the short answer. And I think I'll stop there. So read the document, but it is okay to have. I suppose part of it is this, that in a lift shaft or a stairwell, we do not expect to have a fire starting in there, and there is no fuel in there other than the exposed wood. So, and most fire engineers don't ever do a fire severity calculation for a lift shaft or a stairwell because there's no ventilation. And if there's no ventilation in a space, and even if a fire does start there, the fire will go out because there's no oxygen. So all of those are all considerations, but I won't say any more.
Thank you. Another question we've got. Fire safety is one concern developers might have with mass timber. What about amenity and repairability following fire in mass timber structures?
Yeah, good question. I would have to say that it's not a lot different from a concrete or a steel building. If you have a severe fire in any building, you've got an assessment and repair problem. And certainly in a lot of steel buildings, you'll have quite big deformations, which not just in the fire compartment, but that'll affect other spaces in the building. In terms of the mass timber building, it all depends on how the fire's been controlled. If the fire's been controlled with sprinklers or the fire service, there'll be very little damage. If it's been an uncontrolled fire, there certainly will be damage, and the protection will have to be taken off. So, but the short answer is the more protection you have, the less damage there will be and the less problem there'll be after the fire.
Thank you. Is there any indication from these documents if the timber is covered or protected by, I lost the question, by a fire-resistant lining? At which level of protection or temperature can we assume there is no charring to the timber during the fire event?
Okay, so the short answer to this is that 300 degrees is the temperature at which charring starts. And so what we've defined encapsulation as providing enough protection, whether it be an intermescent protection or a gypsum board, so that there's no charring. The wood temperature does not reach 300 degrees during the fire severity. So then the issue here is, this is where there's interaction, because you've got to talk to your fire engineer. Is this a 30-minute fire, a 60-minute fire, or something different? And then you have to talk to the supplier of the protective material. And if that podcast I'm talking about is actually saying that in some cases, the biggest danger is actually the falling off of inadequate protection, because if a whole layer of jib all falls off at once, then you can get your second flashover. Lots of questions there, Emma. You go.
We'll get through as many as we can in the next few minutes. Are you able to comment on the availability of fire-rated adhesives in New Zealand?
Okay. Fire-rated adhesives, there are lots of questions about that, and there are different requirements in Europe and the US. And what we have recommended in our document is that if the building has a sprinklered building more than 18 meters escape height, then fire-resistant adhesive should be used. I did make a phone call to Red Stag yesterday because I guessed this question would come up. What I'm told in terms of Red Stag CLT being made in New Zealand, they do not, the adhesive they use is a very good adhesive, but it's not a special fire-resistant adhesive for two reasons. Number one, they have not had the demand for it, and number two, it's quite a bit more expensive. So there are more expensive products available, but you only need them when it's going to be a problem. The other issue about the fire-resistant adhesive is that most CLT available in New Zealand and Australia, the outer lamination is 42 millimeters, and it will take, and if we're looking about 1 hour, 60-minute fire resistance, then the adhesive is only just going to start getting hot at the end of the fire. So if you had very thin veneers, then it would be more important to have a fire-resistant adhesive. But talk to the CLT supplier about that.
Do you know anything about the reason that New Zealand's rating for tall buildings is so much lower than other countries?
Well, it's all about committee decisions. And I think what happened in the 1990s, before 1990, we didn't have a New Zealand building code. Every city had its own building code. And then when we got a new building code, performance-based building code, and there were committees set up to write the different parts, I'd have to say the people who wrote the fire section were, I still don't like their attitude. It was sort of, how low can we go with this? Let's see how clever we are and get these fire resistance ratings as low as we can. And they're fine for small buildings, but they're not fine for tall buildings.
Thank you. For the W100 and W200 scenarios, is this based on the floor area of the room or the fire cell, or how is that considered?
Yes, they may not be perfectly clear in there, but, and I don't know that it makes a difference, but I would say it's the fire cell. And it's just a method of restricting the amount of wood available. But it's on a fire cell basis.
Is there any different fire protection requirements to protect neighboring buildings with tall timber buildings compared to steel or concrete buildings?
No, there are no different requirements. But I'd have a look in chapter 3 of the commentary, because Colleen has addressed the issue of larger flames out the windows, which could make a difference. But there are no requirements, and it really has to be addressed on a case-by-case basis.
Does the guidance document modify the group rating requirement for exposed mass timber in single-story buildings with crowd?
Crowd, yes, I saw that from Crispin. Hi, Crispin. No, the short answer is no. In the guidance document, basically what we've said is for 1- and 2-story buildings, regardless of occupancy, it's business as usual. Because, I mean, there might be a bit of extra fire load on the walls, but who knows, next week you might have a whole lot of fire load in your exhibition or whatever else you have. So that's why it's height related, and crowd or no crowd, we don't regard that as a problem. The other thing would be that in a large open space, the walls don't have a big impact because there's a small number of walls per unit of floor area. And the ceiling might be an issue, but it's not included in the guidance. I'll stop there.
At another seminar, it was mentioned that the strength of timber reduces at elevated temperatures as low as 100 degrees. Should this be accounted for in the design? Should a factor of safety be introduced?
Yes, that's correct. And that is addressed in the principles of that are addressed in chapter 12. Have a look at chapter 12. And because this is a sort of a new problem that has not been identified worldwide until people started building tall timber buildings very recently, the design rules for that are a bit unclear. If any of you are going to the FENZ conference in Wellington next week, on Thursday afternoon, Cameron Douglas from our office will be giving a paper on that topic at the FENZ conference.
Does the application of the supplement to the AS2 or VM2 constitute an alternative solution? And if so, is a further step of demonstrating compliance with the building code required?
You have to ask your TA that question. We can't answer that question. But certainly, if you're in Auckland, talk to Ed Claridge, because he was very much part of this, and he's been communicating with the other TAs. But so I can't answer it, and I think that our hope was that it would not have to be an alternative solution. You could use CAS2 or CVM2, and that would be accepted by the territorial authority if you followed the guideline, but only if they decide.
Yeah, that makes sense. We might have time for one last quick one. What is the justification of unlimited exposed timber for buildings with escape heights of less than 4 meters?
Well, that's just where I was before. It's to do with the risk, and let's work backwards. The bigger risk with fire in a mass timber building is to do with life safety for people who are living high up. Something else I heard in that podcast I'm talking about, they said in the UK, people are not building tall residential buildings out of mass timber. Because I'm not sure why, but just because there's a much higher risk. And for 1- and 2-story buildings, the risk to occupants is very low. And if everybody gets out and the building burns to the ground, is that a problem? Probably not.
Thank you. Sorry we didn't get to the last few questions. There was a lot, but thank you for all your questions. Thanks very much, Andy and Robert. And Have a good rest of your day, everyone.